Now for combinations. This is the second half of this topic, and it goes very closely with permutations. The setup is very similar. So combinations are very similar to permutations. The one distinction is that in this case, order does not matter. So the idea is we're still selecting from a collection of n objects, and we're selecting some subset. But the difference now is that we don't care what order we select them in. So the distinction would be when we looked at permutations, we had the example where we were selecting from a student club, president, a vice president, and a treasurer. In this case, it would be more like selecting a committee where the ordering within the committee is not significant. All that matters is which one you get. So if you have 5 objects here, I could select this one, and this one, and it doesn't matter which order I selected them in. All you're looking for is which ones we've grabbed and which ones we haven't grabbed. And so the question is, how many ways can we do that? Which sounds complicated, and you can start thinking about the issues that come up and how you would count this sort of thing. But with a little bit of background in permutations, it turns out that it's not nearly as bad as it sounds. The first question you should think about as you're reasoning this through is whether, for a given situation, the number of permutations or the number of combinations will be higher. So think about which one will be higher. Let me give you an example while you think about that. So let's say we're going to select 5 people from a group of 12. So the 5 people from a group of 12 are going to be chosen to work on a project together. And the question is, how many ways can we select these people? So how many combinations? So think about this. Are there going to be more or fewer combinations than permutations for the similar situation? So the permutation problem would be if we were to select 5 people from this group of 12 and arrange them somehow. So the question is, are there going to be more combinations or more permutations? And if you want to pause the video for a minute and just think about this question and see if you can come up with an answer, I'll try to explain in just a second the answer to this question. So the question is whether there are more permutations or more combinations. The answer is that there are more permutations, and the reason is for a given combination of people, so if we select 5 people, those 5 people can then be ordered in 5 factorial ways, right? So if I've selected 5 people, the number of ways to order them is 5 factorial. So one combination leads to 5 factorial permutations in this example. Of course, that would be different if the numbers were different, but one combination that we can select out of this group of 12 leads to 5 factorial permutations. So there are many, many permutations for selecting 5 from a group of 12, but with one selection of 5 people, we then have 5 factorial or 120 ways to arrange them. So it turns out that to go from permutations to combinations, all you have to do is to think about this correspondence. And if we knew the number of permutations for this problem, which we should know by now, all you have to do is divide that answer by 5 factorial in this example. And once you know that, combinations are not super scary because we know what to do with permutations. We know how to calculate those. And so as long as we can divide by the right number here, we'll be able to get the number of combinations. So notice where the 5 came from. That was the k in our problem. So that's the number that were chosen. So all we need to do is take the permutation formula and divide by k factorial, and that will give us the combination formula. So I'll show you that in a minute, but first let me write down a little bit of this detail here just so it's saved in the notes. The idea is, first, we start with the permutations. So with this example, we have 12 to choose from, and we're selecting 5 of them in order. So we have permutations with 12 and 5. That would be 12 factorial over 12 minus 5 factorial, or 7 factorial, which, in case you're curious, works out to just over 95,000. So once we have the number of permutations, then we divide by the number of ways to arrange the ones we've chosen. To arrange the chosen 5, which is just going to be 5 factorial. So our answer is going to be the combinations where we're choosing 5 out of 12. It's going to be what we had before. But then we also divide by 5 factorial, so that just shows up in the denominator as well. And it turns out that if you take 95,040 and divide by 5 factorial, or 120, that works out to 792. So as expected, the number of combinations was significantly lower. In general, permutations, there are many more permutations for a given number of combinations, just because of that idea that once you've selected however many you've selected, then you have a factorial that determines how many ways to arrange those, which leads to many more permutations. So in short, the formula for combinations looks just like what we wrote down, but in general terms, with n and k, you start with the permutation formula. We have n factorial over n minus k factorial. And then you also divide by k factorial, whatever k is. In our example, it was 5, but for other examples, we'll use k. There's another way to write this, another notation that you may or may not have seen, but it looks like this, where you have n written above k with parentheses around it. And this notation is commonly used, and you might read this as n choose k. The language there means you have n objects to choose from, and you're choosing k out of that group. That's the number you're choosing. So familiar terminology, but you may see that in other places written that way. There's another name for this, which is called the binomial coefficient. And we're going to come back to that later and talk more about that. But we'll leave that for now, why that's called the binomial coefficient. So the formula for combinations, again, looks somewhat complicated at first, but knowing where it comes from, it's, again, based off of things that we are familiar with, and all of these are ultimately building off of the product rule. So that's really the foundational piece that builds up to permutations, and then with one more step, builds up to combinations. So I'll make a separate video to show you how to find these on your calculator, and then we'll do some examples as well.